Hello, and welcome to my presentation for A2610 on Lab 2, the Rijke tube. My name is Raghu Bharadwaj, and I am in section A9Y of the class. So what is a Rijke tube? A Rijke tube is a category of postcombustor, which consists of a long tube with a heat source. Now because the way the heat source burns, the heat is variable inside the tube, and this causes a fluctuation in pressure. And this, paired with the nature of the tube, creates acoustic sound waves inside, which can be heard throughout the experiment. Now, the tube itself was named after Dutch physicist Petrus Rijke. The main subjects being studied in this experiment are both resonance and pressure, and this will become more clear as we analyze the data from this experiment. Now, what is the significance of this? Well, the postcombustor is one of the most efficient ways to burn a combustible gas. And this is due to the air and fuel mixture in the tube itself, and this increases the combustion intensity. And this is a very significant topic to be studied while creating better technologies in the field of combustors and engines. So the approach to this experiment is as follows. First, we start the burner at the bottom of the tube and raise it to the zero position, or known as the origin. Then we record the measurements through the computer system, and this auto-generates a data table with the various pressure readings and the voltage readings as well. Next, we move the burner to the next location. In this experiment, that was 2 inches above the origin and 6.5 inches above the origin. Then we repeat the same measurements for those positions. Now in the tube itself, there's an option to have the valve open or closed. We tested both open and closed valves at the origin, but kept the valve closed at 2 inches and 6.5 inches. Now here's a display of the Rijke tube setup. At the top, the small spike is the pressure transducer, and there are 3 of these throughout the length of the tube. And the black perpendicular cylinder is the photomultiplier. And in the middle, as you can see, is the actual flame being emitted. Now here's the first data table generated from the experiment. As you can see, there are the 4 different positions that we tested, along with their frequencies, which were generated through the computer system in the data table. Now the amplitudes were originally given as voltages, which were then converted to pressure per square inch, and that was then converted to amplitude in the units of decibels. And the next table is the frequency and RMS of the PMT signal. As you can see, the 4 conditions again we tested, and both the frequency and RMS, which were both generated through the computer systems in the data that we collected. And this equation here is the estimated tube resonance frequency. Now the equation for this is F equals square root of gamma RT over 2L, where gamma is equal to 1.4, R is the gas constant equal to 287, and T is the temperature of the room on the day of the experiment, which converted from Fahrenheit is around 295.9 Kelvin, and L is the length of the Rijke tube itself. Now computing this gives us an estimate of about 94.27 Hertz. This next table generated is the relative phase angles of both open and closed position of the origin. Now, as you can see, there's the different readings for pressure 1, 2, and 3, as well as the PMT signal. And as you can see, the relative phase angles change pretty drastically depending on the different pressure transducer. So the conclusions from this experiment are as follows. Both resonance and pressure change with the location of the flame, and this could clearly be seen through the data. And the pressure valves differ depending on the distances to the flame. Now the answers to the supplemental questions are as follows. For number 1, a 415 through 450 nanometer filter could not be used, and this is because the chemiluminescence of hydrocarbon lies in a different range of 306 to 311, so therefore the data would be inconclusive. Secondly, I believe the experiment could work with the different fuels such as hydrogen, but I believe the ranges of the values might be different just due to the gas being different in the way it burns. And thirdly, a tunable Rijke tube could be designed, and this could be done through an adjustable length, thus making the frequency variable. This would be akin to a valved instrument such as a trombone or even a flute, where the pitch of the instrument is changed through covering holes or changing the length of the instrument itself. Thank you for listening to my presentation.